Hey, sorry about that. So I had a couple of issues just getting my streaming to set up there, but never mind. So what I want to do today is I want to have a look at the thing we were looking at yesterday, which was looking at this function that we'd written to detect faces using Machinebox. And what I want to have a look at is how we can make this testable. So whether you're using serverless with Go and OpenFAS or Lambda or Google Functions or Azure Functions, predominantly the pattern is centered around this very simple handler pattern. So I just want to have a look at a way that we can actually make this testable, because it's quite painful having to compile and upload and run the tests on this every time. But before I do that, I want to show you why I'm building this thing. So what I'm trying to do is I'm trying to build some object recognition. I've already got some stuff that does facial recognition, and the reason that I want to build it is for a project that I'm working on, which is this. And this is a project which I'm currently calling Selfie Drone. And what Selfie Drone does is it's an autonomous drone that uses facial recognition, so it'll actually follow your face as you move around, and then it'll tweet pictures to Twitter. Well, because. So what I've actually done to build this is I've got a microservice architecture and I've got some serverless in there. It's all event-driven using Nats.io. But this is basically a Parrot mini drone with a Raspberry Pi Zero and a Pi camera stuck to the top of it with a couple of Lego bricks. So the Pi talks to all of the server software. It then uses Bluetooth to talk to the drone, and the thing will fly. Let me see if I can quickly show you this working. Okay, so if I run my, oh, sorry, just put my mic down. If I run my drone control software, and then I'm actually just SSH'd onto the Raspberry Pi here, so I'm just going to manually run my drone control software actually on the Pi itself. I'm going to give it a command to connect. You can see in the bottom window there that it's connecting to Bluetooth to the mini drone, which isn't actually switched on, so give me a second. So that connects to the mini drone over Bluetooth. And then what it does is it broadcasts a frame from the camera attached to the Raspberry Pi, and it sends it over through the server, does some object detection, well, face recognition, which it's not going to pick up very well because it's quite dark in here at the moment. And what we can also do is we can control it using messages that we send via the API. So if I tell it to take off, you see there it's taking off. Let me just switch that to full camera mode and try and move out the way a little bit. So I can tell it to move forward. And slowly it's going to come into view. And there it is. So that's Selfie Drone. and I'm just going to get that to land. So that's what I'm building. I'm building this hopefully autonomous drone software, and I'm going to use a combination of microservices. I'm going to use functions, but ultimately it's all going to be written in Go. All right, so back to the task at hand. So what we're going to do is we are going to look at how we can make this function testable. So there's a couple of things that we need to do to make this testable, and one of the things that we need to do is we need to have a look at this handler here. So the handler has got a number of dependencies. It's got a dependency on this Facebox client. It's got a dependency on image decoding. That might actually be okay to leave in line. And then we've got some stuff around drawing the images and the graphic context, and then obviously writing it back out. So the way that this function works is that it is literally just a single function. I don't have any sort of complex packages other than the ones I'm importing. There's nothing in the tree. So what I need to do is I need to work out how I can unit test this. And let's have a look at the first test. So the first test that we probably want to have a look at is something around this here. So we've got a check, and then we've got an error statement. So we want to kind of write a simple test around this. But how do we do that? How do we write a test when we actually have to instantiate Facebox, and that has to come up against a server? So the first thing we need to do is we need to start looking at how we get the dependencies out of this function. Now, ordinarily, you can do simple things like using parameter injection. We could use globals, which is slightly frowned upon. But ultimately, the problem is that we've got this handle function. And this handle function is a thing that's called by the kind of the main sort of serverless function. So we kind of want to test this entire function as an input and an output to get the best quality out of it. And because of that, we need to work a way of getting out these dependencies. So we'll have a look at some simple ways that we can do that. So the first thing we've got here is this functional test that we wrote last time, which was just to aid us when we were writing this code. Now I said I was going to do TDD, but what I'm actually going to do is I'm going to show you on the existing function how we sort of mock out the dependencies. Because actually, if we understand how we sort of mock out and replace dependencies, then that makes TDD super easy. But we're not actually doing TDD from a perspective of test first or test-driven development. We're looking at a way that you could do TDD, and maybe in a later video we'll code up one of these functions in 100% in a TDD style. So the first thing we need to do is we need to look at this dependency. So we've got a dependency on Facebox.new. So one of the ways that we kind of want to handle this is what would be good to have is maybe a function which creates all of our dependencies. So in Go, if I create a reference, and I'm going to call it dependencies. And what I'm going to do is let's just call it deps. And it's going to be of a type deps, and it's going to be func. So it's going to be a function, and it's going to return initially a whatever facebox.new is. So facebox.new returns a Facebox client. Right, so we can do something like that. And then what we can do is we can just create our implementation of that. So I'm going to call it dependencies, and it's going to be func facebox.client, so the signature matches. Oh, sorry. And then what I'm going to do, I can return facebox.new in there. Okay. So now, valid operations, see, what's it complaining at? Oh, because I'm not calling it, sorry. All right. So now what I've done is my dependencies are created by this dependencies function, which is actually assigned to a variable here. Now, what I can do in my test is I can override that. So if I create a setup handler in here, let's just call it setup, it's going to be testing.t. Then what I can do is I can say dependencies equals func facebox.client, and I can basically override that. So in my actual test, so I'm going to say func, well, let's just check that we're checking for something. So test checks for, checks calls facebox check. So I just want to write a test that I'm actually calling Facebox check. And I can actually just do my setup is the first method in there. T. And then I can do execute and assert. So that's your classic testing setup. You have a setup, an execution, and an assertion. So now what I've actually just done is I've created a way that allows me to replace the dependencies inside of my handle function. But that's not far enough, because what I'm actually doing still is I'm returning a brand new instance of facebox.new. So I need to, because I've set this up to return an instance of facebox.client, I've actually got to return an instance of facebox.client, which is not ideal because I don't want to return a concrete implementation of that client. I want to return either a stub or a mock of the client. So let's have a look at some nice things that we can do in Go that'll allow us to get around this. So we've got the concept of composition in Go. We've got the concept of duck typing. So one of the things that I want to do is, rather than returning a concrete implementation of client, I actually want to return an interface. So what is that interface that I want to return? Now, I don't need to return an interface which has every single method that facebox.client. What I only need to do is have the methods that I'm going to use. So in this instance, it's the check method. So I can define my own interface, and I'm going to call it type facebox checker, and that's an interface, and I'm going to add a method onto it, and the method that I'm going to add onto it is going to have the same signature as this check function, which is that it takes an IO reader and it returns an array of faces and an error message. Right, so something similar to that. Now this has to return facebox.face. So now I've got my interface, which has the check method on it, which is the same signature which is returned from the client.check. Instead, what I can do is, instead of returning this concrete implementation here, what I can do is I can return my interface. So now my code is depending on my interface rather than the concrete implementation. So let's just give that a name, facebox checker defines checking, oh, I don't know. Naming is literally the hardest thing in writing code. Anyway, so now though, if we go back to our test class, if you remember the problem that we had when we were looking at writing replacing those dependencies, the problem was that we all were bound to this concrete implementation. But we don't need to do that anymore, because now we're bound to facebox checker. So instead of doing facebox.new, what we can do is we can replace this with a mock. So there's a couple of packages which I like to use for mocking in Go. I have to say they're both made by Matt Raya. Testify is possibly the first Golang package that I ever used. It's a lovely package for assertions, and there's a great sort of mocking package in there as well. But one of the latest sort of packages that Matt has been working on is called Mock, M-O-Q. So I'm going to give Mock a go, because one of the things that I like about Mock is that using Go Generate, you can actually generate your mocks, which makes your life a little bit easier. So there we go. You can see that that's on Matt's GitHub at github.com/mattraya/MOQ, and I'll stick this in the links. So how do we generate our mock? Well, it's quite simple, and one of the nice things is that we use these Go Generate statements. So we just put some annotations in our code. So if we go back here, and we want to put that on our facebox interface, so we're going to give it a name. It's facebox checker. Sorry, this is a little bit dull, but so we're going to do Go Generate Mock. The output is going to be facebox_mock_test. Because we're pushing this into a test class, it's not going to expose it out to any of the other classes to misuse. And then what we do is we should just be able to call Go Generate, and then that will create our mock for us. So let's have a look at that. So Go Generate, what's it saying? Blah, blah, blah. Okay, so there we go. So we've done Go Generate, handler.go. That's then indirectly called mock, which I've already got installed. Just go get it. And then I've now got my mock Facebox client, which is Facebox_mock test. Right. So now, if I open up that that file, whoops, we can see that it also generates us a little handy cut and paste that we can use. So I'm just going to copy that. Let's go back to our test. And I'm going to paste that into my setup. So I'm creating this Facebox checker now. Let's leave the panic in there for the time being. I'm setting my dependencies. So instead of returning Facebox.new, what I can actually return is my mocked Facebox checker. So now, when I run my test, what should happen is in the handler function, I'm going to get my dependencies. Now, it's not going to call these dependencies because I'm replacing this with my test dependencies on which is happening in my setup class on the right-hand side. It's then going to do c.check with the bytes.reader. That, of course, is going to come into here rather than into the actual Facebox, and it should blow up. So let's see if that does happen. So I'm going to do handle. I need a byte. Oops, whatever it is. What am I doing wrong? Isn't that a byte array? Oh. Okay. So I'm going to cause handle. That will be null, but we just want to see this blow up. All right. So let's clear that. So if I do go test dash the verbose, and you can see it has. It's blown up, and the message is panic to do mock out of the check method. So because we've replaced our actual implementation, our runtime dependencies, now with our test dependencies, we've also got the capability that we can have unit tests which don't have to call the actual Facebox API, which of course won't work if you don't have a Facebox server. So that's going to give us the capability to write unit tests for this handler. So let's have just a quick look at writing that unit test. So the first thing we want to do is get rid of this panic because we want to return something. So for the time being, I'm just going to return nil and nil. And what I also need to do is I want to grab an instance of mock Facebox checker. So I'm going to return that as a return from my setup function. So let's give that, if I can find the right key, Facebox checker mock. And of course, cool. So now in here, I can do m. So that's going to be my mocked Facebox checker. I'm going to do the handle. So I've got a function here which says test call Facebox check, and I want to write an assertion that is going to happen. So let's have a look at how we can do that. Now, I don't particularly care for using the Golang's very, very sort of raw testing framework. So I could write something which is something like this: if blah, 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 then t.fail or t.fatal or something like that. So if blah 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 dot 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 t.fatal blah, like that. And the reason that I don't use these when I'm writing my code is because it's not expressive enough for me. So I've got to decode what that assertion is doing. And I think a lot of the sort of the concept behind Golang is that you get these great baseline packages and you build upon them. So I'm kind of torn between two frameworks at the moment. There's one called is, which is super simple for writing assertions, and there's also Testify, which I mentioned earlier. I'm going to use is, so let's have a look at that. Unbelievably, it's Matt again. By the way, and I didn't realize this until I first met him, but Matt and David are the two behind Machinebox. So Matt's got a bit of a pedigree in this industry. And I remember the first time I met Matt, and I think it was in Golang UK back in 2016. And I was talking to him, and I didn't realize that he wrote Testify. And I was like, that was the first ever package that I used in Go, because literally the first wall I hit when I started to write Go was I was used to working with NUnit and things like that, and JUnit, and I felt that the testing suite was a little bit too raw. And so I Googled, came up with Testify. Small connection, completely not related to a great deal at all. But anyway, is the latest framework that Matt's been playing around with, and I like this because it's super simple to write your tests, which makes them really readable. Again, think about code is there to be read. You know, you spend more time reading code than you do writing it. The machine doesn't care how you write your code as long as it's syntactically correct. But the machine doesn't care because it's a machine. It's not a human being. Machine code is for humans. So we're going to use is. So I'm just going to grab that package. Stick that in my import, and then in my test, I'm going to return, I think it's is.new, I can't remember, and I'll take t, I would guess. I can't remember exactly what the interface is. Let's have a look. Oh, I need to put this in brackets. I literally have the worst memory in the world when it comes to coding. It's amazing that I actually get anything done. So it's is.new t, and that returns you a type of something. So let's have a look and see what this is complaining about. 47. Oh, right, yeah, that junk I was typing before. Okay, so of course I just need to dep ensure to pull down that testing package into my vendor folder. And that's done. And let's just figure out what type this is. So it's running a reference of is.I. Okay, not is.t. Cool. So I'm going to return m, I'm going to return is, and then what I want to do is I want to check that the check function on our Facebox client has been called. That's just my simple assertion. So I write is dot equal, and we're going to use a value of 1, and we're going to say len, so we're going to get the length of the mock dot check calls, which returns us a strut. And then the nice thing about it is we're just going to write the reason behind our assertion here. We're going to say should have called check. And I'm missing a bracket. Cool. So now when I run my test, that's going to pass. So let's make it fail. I'm just going to break the code deliberately just by returning nothing here. Run my test again, and you can see that the assertion is now failing. And I've got a nice output in my testing thing, and it tells me that the thing that's failed is I should have called check. The expected value was 1 and the received value was 0. So that's it. It's Saturday night and it's evening, but we can maybe continue with this a little bit more, and we can work through and sort of replace out all of these things, because the next important thing that I want to show you is that now we've got this mock, what I can actually do is I can control that's what c.check returns. And I can do that based on what my test expectation is. So I want my next test to be that if check returns an error, I'm returning an error message to the user. So I can write my next test, facebox with error returns error. And this is going to be the next thing that we're going to work on. And up here, where we're just returning nil, because we've got this mocked facebox checker, I can force this to now return an error. If this was hitting the actual facebox endpoint, it's going to be a lot more difficult to get it to force it to return an error. Certainly not predictably. Again, plus to the fact you're running your tests on CI. You want to be running your tests fast. You don't want to be running them against the actual API implementation. Not at this stage. That's so much later. And that's it for right now. We got comments saying, just a heads up, you can do test main for the tests. Yeah, I kind of like this method because it's very distinguished using setup from anything that's prefixed with test. I find it easier to read, but that's a very valid point. There's a great link down there to have a look at the Golang testing. I see I'm using Nats. What do you think about it? I'm a great fan of Nats. I'm actually using Nats streaming in my selfie drone project. Big fan. I think it's a great free piece of software. Amazing team working on that. Nats normal, so the standard Nats daemon, which doesn't have the sort of the streaming capabilities, is incredibly fast, incredible throughput. Streaming is a great system, great server. For me, I don't want to run the complexities of having to set up Kafka or something. Nats is incredibly lightweight. I've actually got it running on my little Raspberry Pi cluster that I use to run all my selfie drone software. So yeah, definitely check out Nats. I'm certainly a fan. So yeah, so until next time, thanks for watching. I'll upload this video, and next time we'll look at how we can start using these mocks to control the flow and allow us to write full assertion. Just before I go, actually, let's just show you a cool feature. If I run Go coverage, you can see in green here, these are the lines for which I've got test coverage. The red lines are stuff that I don't have test coverage for. This is actually not correct. That's coming back from the Go cover package incorrectly because I haven't got a test for that. But this is a really, really useful tool that you can use if you're a little bit unsure about whether you've missed something. When you're writing your tests, Go cover literally has you covered. But yeah, next time we'll dive more into this. These techniques that I'm showing you here are only are not just applicable to writing Go. They're not just applicable to writing serverless with open files. You can use a similar technique whether you're using Node or Python or Ruby or anything like that. It's the principle of replacing your dependencies, checking, writing your unit tests to save you the trouble of having to go through a slow test cycle of compiling and running your application on a production server or a dummy server or something like that. It's a nice way to work. But on that, till next time, have a great weekend and thank you very much.